Okay, Jacob just made a good comment, so I hear everybody. Come on, look at me. Everybody. Listen. Okay, he said we need to be focused on concepts for these last 22 days. So here's a big concept. When they talk about in problem number 3, a line tangent to a function, line tangent to some function called f. Okay, here are the big ideas. F is a set of xy pairs. F has an equation, F has a curve, F has a graph. We don't really care to sit and ponder what F looks like, so I just draw F like this. So everybody, look. Any problem in the future, they start talking about a function, if you're not really sure, just draw this. It's as good as any. When they say the line tangent is a totally separate function, meaning, I'm going to turn off my stereo for 1 second. The line tangent is another set of xy pairs. The line tangent has its own formula, and it's that other formula that they're asking us to determine. So you have to memorize the other formula, but because it's the formula of a line, that memorization is a bit easier. So somebody help me, what's the formula for the equation of any line? Emily, please. Go ahead. Just story.
Y equals m and then parentheses x minus x1 parentheses plus 1.
2 pebbles. So mark them down. So you mark them down and I'll pay you later. So everyone needs to have that memorized. So this is the formula for finding the xy pairs that belong to this blue line. A little bit tilted this way too much, but I'll try to leave it. F of x is the formula that goes with that. What's the formula for f of x on this one, Alex?
It's x times 1 minus 2x cubed.
So here's one formula that matches up with these xy pairs. Here's another formula that matches up with these xy pairs. You do have to have memorized the meaning of the symbol m and the meaning of the x1, y1. So somebody can, what are the meaning of those symbols? So Jacob?
M is the slope and the x1 and y1 are the words
I would memorize it slightly differently. M is the slope of the line. How many slopes does this line have, Jacob? Just one. Jacob, how many slopes does this curve have? Perfect. So M is the slope of the blue line. 2 pebbles for Jacob. Somebody else help me. Just some questions here. So Matt, how many points does this blue line have? Infinite number. X1, Y1 is actually any point on that line. Like, memorize that. That's really the core idea. It's any point on that line. They tell us this point, so yes, that's the most convenient point to use, but it really could be any point on the line. Like, it's not really smart to memorize that it's always that point. It's best to say, oh, it's just any point. I'm going to use that one. So, 2 for Matt. Anybody else? Awesome. Okay. So all we really have to find now is the slope right here of the blue line. But m is something else as well, because the blue line is tangent to f. M is the same as the tangent slope of f at that point. And what symbol represents the tangent slope of a function? Please.
F prime.
F prime. So we have the formula here for f. So our goal now is to go find the formula for f prime. We can use that formula for finding any slope along the purple line. So we've got to find the derivative of that. I don't want to really do all the steps again. here they are. So steps 3 through 7, I'm computing the derivative of f. And right here is where I find my formula for f prime. So feel free to, feel free to ask anything you want about any of those steps. This is all on my website again, so. Questions from anyone? Once we find f prime, we use that to find, in fact, I'll take 2 more pebbles for this one. Somebody originally told me, what's the meaning of the symbol f prime of 1?
The slope of that.
Thanks. So that's the slope of f when x is equal to 1, which is right here, that's what we want. That turns out to be the exact same thing as the slope of the blue. So, for Alex. Any other questions on this? I've answered your questions, Alex.
Yeah.
Anyone else have a question here? Anyone else bring a different question from the green class? Please, Julie. Okay, it's an area problem, so my first task is to identify visually the appearance of the area. So as you read the problem, Julia, it says the area is bounded by, what's the first thing that it says?
Y equals
E to the what, sorry?
e to the 2x.
Thank you. That will give a pebble to everyone in the whole class for this one. As soon as you read and write down, or even just read the symbol y equals e to the 2x, there's a very important fact that you should immediately recall from memory with regard to this particular equation. You can actually give you 2 pebbles for this one. I'll pay every single person 2 pebbles if they can read my mind. Like, what am I thinking as soon as I see that? Like, it's something I've reminded you of a lot throughout the year. We haven't said it much since December, and in December I said it kind of repeatedly, like over and over again. We see a function e to the 2x. We've got to remember something very simple but important about that function. 2 pebbles for all we remember. What do we have to remember? Let's go, Blake.
Is it that it's the same thing as e to the 2x plus 0, like the x plus b to the 2x plus 0?
I'll give you 2 for that. That's smart. That doesn't come up right away, but it will, and that definitely important. It wasn't what I was thinking, but I like that you said it. I didn't think of that at all. Anybody else think what Blake was thinking? 2 for that one. Who else has a different idea? So Emily?
X can't be negative.
Super close. I'll give you 2 for that as well. It's not that x can't be negative, it's that e to the 2x is always positive. So x could be a negative value, but e to the anything is positive. So, anybody else have their hand up and knew that before I said it? Okay, get that memorized. Every time you see e to the something, it's a positive function. There are no negative values. E to the whatever is always a positive value. Question? So that allows me to think about this function a little more simply. It's not something really complicated, it's just some positive value. So what's the next boundary, Julie?
The x-axis.
So I'm drawing a picture here, x-axis. I'm thinking, here's the x-axis. Next boundary?
The y-axis.
Y-axis. And again, because this is always a positive function, I may not remember exactly what it looks like, but I know that it's always up here. And I kind of remember that exponential functions go like this, so.
And then, x equals 2.
And then x equal 2 is a vertical line here. So now I have my boundaries. I can see that this is the region I'm trying to find the area of. And so I remember, better, that, let's see, I find the area, rectangle after rectangle. So that means I'm looking here. This rectangle, and then several others, then this one. So here's something, I don't know if I've said this in class very much, but I would like you to memorize it. I'm going to start saying it more. We find area by integrating length. Okay? I'm telling you that because it fits well with what we introduced last time. We find volume by integrating cross-sectional area. So we find area by integrating the length times the width, but the width is just dx. We find volume by integrating the cross-sectional area times dx, which is the thickness of the slice. So I want that to be memorized because that will really help. Find area by integrating length times width. Find volume by integrating cross-sectional area times width of the slice. So let's see, here's my length. So length is the y-coordinate at the top, subtract the y at the bottom. The y at the top is found using this formula. The y at the bottom is always 0. So my formula for that area is integrate from the beginning point, which is x equals 0, to the ending, which is 2. Take that function, subtract 0. dx is the width of each rectangle. So this is the length of the rectangle, width of the rectangle. So integrating length times width gives me area. Questions? Please.
Where do you get the x equals 2 for that boundary?
And so in the problem statement it says, area of the region bounded by the curve, and then x equals 0. So now I have to remember, okay, how do I find an integral without my calculator? I have to use the fundamental theorem, which says I have to find the antiderivative. So let's do that. So it's the ax plus 0, so it's 1 over a, e to the ax plus b. That's the antiderivative. I calculate how much the antiderivative changes between 0 and 2. That's going to give me the area, or the value of that integral. Follow-up question. And then the steps to that are here. First part was finding all the boundaries. The last part is the actual computation. So, numbering the steps, this is 1, 2, 3. I'm going to run out of room. You wouldn't want to ask about any of those steps. Julie, I've answered your question. You guys have a different question about within the classroom. So I joke with some people that the green sheet I gave you early in the year has 16 different derivative rules. The rule you need for this one is rule 17, which is how do I find the derivative of an integral? And I don't need to do a lot of thinking on this one. I can just apply the rule. The derivative of any integral is always going to be the integrand. So these two are the same, except that I replace all variables of the integrand with the upper limit. And then I multiply by the derivative of that upper limit. And then it's minus the exact same thing for the lower limit. So from here to here, it's just straight memorization. It's a case where you don't really have to know a lot of y for our class. You have a follow-up question there. Cleans up really fast because the derivative of this constant is 0. These two multiply to be 0. This is 1. So that's it. Please.
What was the last on 15? Oh, 16. So, we're finding the
Your question is really straight.
also, like, we're not finding the antiderivative, right? We're just finding.
Yeah, let me. I think I'm going to try and guess kind of what's causing a little bit of uncertainty as you talk with me. And if I guess wrong, I'd like you to keep talking. But let me just try something. Is that okay? Here's what I think's causing me a little bit of trouble. And we'll give some pebbles away to the whole room on this one. Let's see. And the last problem really was about area.
Yeah.
Okay? And one thing you have to remember is that we can use integration to find area.
So when
Talk to me.
that area you don't choose, when you choose the limit, that's my question, like, because on some of the problems, like in a couple packages ago, we were changing the limit. Is that when we're doing antiderivative? We have to change the limit?
Let me keep talking, and you keep asking. You've been trained. I just got to kind of consolidate all the things you're thinking. So the last problem, 15, we were supposed to find area, and we have to have memorized that we can use integration to do that. So are we good there? Okay. Now here's the question for the whole room. On the AP test, you're going to be asked to find the value of integrals in multiple ways. We'll pay pebbles for those who can raise your hand and tell me. What are the different ways you're going to be expected to be able to compute integrals? If you've done, let's see. So far we've done it 3 different ways. We're going to add a 4th soon. The 4th you kind of already know. We just haven't practiced on problems. So what are the different ways we find integrals? We'll pay for this. Let's try Carrot.
Riemann sum.
So one way is they'll ask you to find an integral via a Riemann sum. Okay, please show me your hands if your hand was raised and you were thinking Riemann sum. Show me. So 1, 2 for that actually. What's another way that you have to be able to compute an integral on the AP test? Hands, come on. What's another way? Alexa? Very good. The fundamental theorem. That's what we did on 15. On 15, we had an integral that we created here. And then to find that integral, we're using the fundamental theorem because we don't have our calculator. I'm almost to the other question here. Just give me a second. So how many had their hand raised were thinking fundamental theorem? 2 for that. There is a third method no one's mentioned yet. It's actually everybody's favorite method. So I've never met anyone who didn't consider this their favorite human. Yeah, calculator. my favorite too, honestly, if they let me do it. So how many were thinking this? Another hand up? Show me. 2 more. Cool. The last method we haven't really practiced, it's also quite easy. Because we can use integration to find areas, we can turn it around. If we can geometrically compute an area, we can use that to find the value of an integral. So we'll do that as well. So this is how we're finding integrals. Now, your question about changing the limits falls in right here. We're using the fundamental theorem to find an integral. First thing we have to do is find the antiderivative. And the ways we do that are, we ultimately have to use a formula. But sometimes we have to do a U sub, or, and or some algebra to get that to work. If we do a U substitution, we change the limits. That's what you're remembering. Is that fair? Is that feeling more subtle? Good. And then just to kind of close the discussion, back here on this problem, where they're just asking us to find a derivative, we don't have to worry about any of that. This is one rule and one rule only. It's a really good question. Get 2 more for Alexis, mark them down. What you just did there is what everyone needs to be doing. Like, you've got to say, okay, wait a minute, we just did this problem, and I've got to see how it connects to this other one, because then I can understand better what rules belong where. It's perfect. It's exactly how your brain wants to sort it out. It's perfect because you're focused on the why. So, any other questions here? You know, let's bring a different question with into class. If you haven't brought any other questions, we'll probably just give you the time to work, and I'll just walk around and do individual help as best I can. But if you brought questions with you, Bryce, 30? So 30 is the same as 8. All they're asking you to do is find the derivative of this formula. And because the formula is an integral, I'm using rule 17. And there's the work, but I'll let you ask about any step, or anyone can ask about any step. So this is what they ask me to do. Here's step 1, apply rule 7. Come on. So step 1, apply rule 17. Probably the pen will work. Well, exactly what I'd expect to happen. There we go. So step 1 is here. Step 2, we're done. Question? Please, Jared.
I have a question, but not about this problem.
Let's check on Bryce. You get here? Go ahead, Sherry.
So a function is differentiable if it's continuous and then if there are no corners or vertical tangents. So if you're just given the equation, can you tell if there's a corner?
Gotcha. I have to give one of those 99% sure statements because I can't quite dig enough into my memory to be positive, but I'm really 99% sure. Everybody here, let's hear this. The only way to get a corner on a function of the type that we deal with is it has to be piecewise. Like, I cannot recall any functions we've ever, other than the absolute value function. The absolute value function has a corner. So function like this will have a corner. And that's a memorized fact. Like I can sit and think about why that's true, but I basically have memorized that the absolute value function does have a corner. But I can't recall any other functions that we've ever dealt with in this class that have corners unless they are piecewise. The meaning of the word corner is the slope changed abruptly. Like the slope was changing by infinitesimal amounts as you follow the curve, then suddenly it just changed dramatically. So visual examples of corners. Those are all cases where the slope changes dramatically. And it can be rather subtle. You can have even something like this where it's still an abrupt change in slope. It just didn't change a lot. But so I cannot really see that without doing some computations. But what I would do is I would find the slope close to where the corner, well, close to where the piecewise function joins. And just compare and say, okay, prior to where the piecewise function changed from one formula to the other, what slope am I finding? And then after that point, what slope am I finding? Those two slopes are different, that's causing a corner. Is that your question?
Yes.
Points. Pebbles. Anybody else? You know, bring a question within the class. Please.
29.
29. Okay, everybody for this one. You have to have memorized the definition of relative mass. And we memorized that earlier in the year. So I'll pay 2 pebbles to every single person who can fill it in. Like what goes in all the blanks? Read the name for me.
I'll take care of all that.
Say it again. So show your hands. You know, what goes in the blanks? Okay, everybody. I gave you a white sheet earlier in the year, had all this information on it. Alex, what goes in the blanks?
So where
I'll start with now. Go ahead.
where F changes, let's see, max would be increasing to decreasing, or where F prime changes positive to negative.
And I really like the fact that as you did that, you were looking at Danica's chart. That's what I do. It's perfect. How many would have said exactly what Alex said? Show me. 2 pebbles. Question. Okay. My number one choice would be to use a graph. Memorize this though. If you don't have a graph, the best option is a sign chart. And memorize that. I'm going to keep asking that for the next 22 days. Okay? If you don't have a graph, use a sign chart. So this is not a calculator problem, and then you give me a graph, so I go to work using the sign chart. So that's why I'm finding F prime. Sign chart can only be built with factors. So I factor F prime. I build the sign chart using F prime. And now I can figure out where F prime changes from positive to negative, which tells me where F has a relative mass. ask about any of those steps. Remember, as we practice for the AP test, we are not trying to recognize, recall, and just do work. We're trying to read and solve a problem. So don't fall into the trap that they're setting for you to just recognize that it's the same problem, just keep doing the same thing. Always solve the problem using the concepts. Any questions here? You have a different question about the computer, please.
On this one?
Yeah, please.
Never mind.
You're good. Double for Peter. Anybody else? You have a different question about looking at clock. Please, Julie. 19. Okay, again, don't read a problem, think you've recognized it from your past and do what you're remembering. Read the problem and solve what it says to do. So the radius of a sphere is decreasing at a rate. Keyword is rate, 2 centimeters per second. I would have stopped there. There's a period. So I would have, on my paper, I would have thought to myself, the radius of a sphere is decreasing at a rate of 2 centimeters per second. Just like I wrote here, that means dRdt has got to be equal to -2 because the sphere's radius is decreasing. At the instant when the radius of the sphere is 3, so that's the next thing I wrote on my paper. There's going to be some instant when the radius is 3. What is the rate of change of the surface area? So they want me to find ds dt. So I'm just reading the problem and writing down what I read so that I can focus on this idea. That's it. So when I look at this, excuse me, I notice they have given me 2 different rates. And so I remember that in many cases, if they give me 2 rates, it's a related rate problem. So I remember the acronym. It's a sphere that is decreasing. So now the drawing would be something more like this. Sphere is decreasing in size. I need to make my Danica's chart. So I've got amounts, and I've got rates. The rates they talked about were dRdt, therefore the corresponding amount is R. They did ask me to find the rate ds dt, therefore the corresponding amount is S. So that's the Danica's chart of this problem. Questions? R was read and write down all the rates. I've done that. EA says come up with an equation that involves these 2 amounts. They gave me that equation. It's right here. The last D in DREAD stands for differentiate that equation with respect to time. So I'm doing that here. So any follow-up questions so far? From there I just plug in the values and solve this. Please.
So where I had trouble was I set the surface area to equal R and then differentiated it. Because one other problem, we like switched it around so that we were finding something else. So
What do you mean by you set the surface area equal to R?
Yeah.
What did you write on your paper?
I wrote like S divided by 4 pi is the square equals R.
Oh, I got you. So you did this. S over 4 pi is equal to R.
Well, it's square root of.
Oh, square. Oh, I got you. This, like that. 2 pebbles for a good question. Eyes on the board. I want to see if your eyes looking good. You don't want to miss what I'm about to say. Okay, gonna have to go with the 99%. I have seen one problem, maybe 2 over the years, where rearranging before I take the derivative is okay. And it doesn't make it harder. I'm not sure it makes it easier, but it doesn't really matter. And I'd say in 99 other cases, rearranging first makes it harder. So it's not wrong, but it just makes the work more difficult. So I wouldn't rearrange. Did you kind of get stuck as you tried?
Oh yeah, that was like.
So I would have just left it and do the derivative first, and then rearrange for what you're solving towards. Figure out. Now bring a question with them in class. Cool. I'm just going to let you work then. I'll just walk around the room and ask your individual questions. Hi. Yeah. You're okay. Hey, no one talking but no one. Quiet. Okay, number 2. Look. All we have to do is focus on the key ideas here. So number 2 gives a function. Function is piecewise. The pieces of the piecewise function are, was it x plus 1, x plus 2?
X plus 2 for less than 4 and 7.
Okay, first one, it has 3 parts to the question. It asks, does the limit exist? To see if the limit exists, we've got to check for values of x that are a little less than 3 and a little more than 3. When we plug those in, we get a y-coordinate that's really close to 5, so we know the limit exists. You want to have a question about that? Okay, memorize fact. The function to be continuous, this has to be true. Like, get this memorized. We had it memorized earlier in the year, just need to re-memorize it. That's the definition of continuity. That's the definition of continuity, so get that memorized. I write it this way because it helps remind me that this is referring to the point that is just a little bit left of x equal 3. This is the point right at x equal 3. This is referring to the point a little bit to the right of x equal 3. And all 3 points must be infinitesimally close to each other for the function to be continuous. Follow-up questions so far? So we've already figured out that the limit, when you take a value that's a little bit less than 3, we're getting really close to 5. When we plug in exactly 3, we get exactly 5. When we plug in a little bit more than 3, we get really close to 5 again. So the two limits are 5, the value of the function is 5. Therefore, the function is continuous because it fits the definition. So pretty safe there. Okay, the third part says, is the function differentiable? Memorize this. To be differentiable, the function must first be continuous. Well, we've checked off that. We also cannot have any vertical tangents or corners. Okay, vertical tangent occurs when the slope, the rise over the run, you end up with a 0 on the denominator. There is no run. That's what causes a vertical slope. Well, this function, we take the derivative of that function, so we find f prime. F prime is going to equal, let's see, the derivative of the first piece is 1, the derivative of the second piece is 4. So the slope can't ever be a number divided by 0, so there cannot be a vertical tangent. We don't have to worry about that. What further talk on that topic? The word corner means the slope changes abruptly, and that's what we see here. For values of x that are less than 3, the slope of the curve is always 1. When the values of x are greater than 3, the slope of the curve is abruptly different. It's now 4. That's what causes the corner. That's why the function is not differentiable. Please.
Can you re-explain the vertical tangent?
So vertical tangent means I have a graph where the function f would have a place where the slope goes straight up, like that.
Yeah.
Because slope is equal to rise over run, it's a condition where there's no run. Like the line doesn't go back and forth at all. And so the run's going to be 0. That's what causes the vertical tangent. But this function has slopes of 1 and 4. There's no way for that to be something divided by 0.
Oh.
A counterexample would be this, Paris. If you had a function that looked like f prime, turned out to be 8 divided by x plus, x minus 2. Well, at x equal 2, f prime, so f prime of 2 is going to equal 8 over 0. That means f has a vertical tangent at x equal 2. Is that your question?
Yeah.
2 pebbles. Maybe later. Keep it.
Could you just it is continuous?
So the thing to memorize on continuity is this right here. The definition of continuity is at a point. So function is, this is the definition of continuity at a point. And I've never seen an AP question where they say, you know, definition of continuity, they just expect you to remember. So I had to find out what's the limit as x approaches 3 from the left. Well, that means I've got an x coordinate that's just a tiny bit less than 3. So that has to go into this formula. So a little bit less than 3 plus 2 is going to be really close to 5. Therefore, the limit is exactly 5. F of 3 means plug in exactly 3. 3 plus 2 is exactly 5. Limit as x approaches 3 from the right means the value of 3 is a little bit more than 3. That's 4 times 3 is 12. 12 minus 7 is 5. So that limit's also 5. So because all 3 are the same, the function is continuous. 2 points, 2 pebbles for equal.
So say you have a function where you have a point missing, but the limits do equal each other. Is that not continuous?
So that situation is common. where the graph would look something like this. So the 2 points that are just a little bit to the left and right, say this is still x equals 3. The 2 points that are left and right are very close to the same y value, so the limit definitely exists. But f of 3 is in the wrong place, so f of 3 might be up here. So the 3 things are not equal, so not continuous. Is that your question? 2 pebbles for that. Anything else? Please. You do. So I'll pay you pebbles for all the lines I marked on that. So I'll hit the door there. But just pull the handle because they've got latches. People lean on the button. So just make sure the button pops out. There we go. Please.
Why are we using 1 4 for the formula?
What's that? 1 and 4.
Yeah, where did we get those?
So this is the formula for f. And f is a piecewise function, meaning it has 2 pieces. So to find the derivative of f, I just find the derivative of each piece. The derivative of x plus 2 is 1. The derivative of 4x minus 7 is 4. So that tells me that the function f has some sort of appearance like this. I don't know exactly, but I know that because the slope of f is always 1, f's going to have a slope of 1 until I get to x equals 3. And then suddenly, abruptly, at x equals 3, the slope of f becomes 4. That's what causes the corner. That is for David. Please.
When function f is it if x is less than or equal to and f prime is not less than or equal to?
Oh, outstanding. Let's get everybody in the room to answer this. So look at the board. Okay, in the function f, 2 pebbles for Ethan. It says x less than or equal to 3, and here it says x greater than or equal to 3. I figured out that f must have some sort of appearance like this, because if the slope of f is always 1, and I remember that's a line, x plus 2. So I've got a linear function connecting to another linear function. But where they connect, a corner is formed because of the abrupt change in slope. So that tells me that the value of the slope, so f prime, when x is equal to 3, that value is undefined. I cannot find the slope at a corner. So Rachel, I have to know why I don't include an equal sign here. I'll pay everybody for this one. So why do I not include an equal sign right there? Like there's an equal sign there, but I can't put an equal sign here. Why? Compare it.
Is it because it's the derivative?
Right, this is the formula for finding every point on f. This is the formula for finding every point of f prime, the slope. So this is representing the slope, but right here at 3, I can't find the slope. So I can't put an equal there, that would imply I can find the slope at 3. So I have no way of finding the slope at 3. So I cannot put an equal sign there. Somebody knew that before she said it? You tell me. You need me to talk through that some more?
Because I know that prime means that it's the slope and the slope. But what does the 1 and 4 type of?
So f prime means the tangent slope at every point on f. Every point. So this is my rule, my formula for finding.
That's like y and x is less than 3.
It's saying on f, if you are somewhere where x is less than 3, the slope of f is going to be 1 for all of those points. And you can see it.
Slope just because it's prime.
Right, because prime means the slope of f.
Alright, so you're still dealing with the original graph of f, but with the derivative it tells you the slope of the f.
Yes, think of it this way. Show another picture. Okay. Two more for Aaron. Look, here's that. We'll play a little pebble game here for lots of people. Okay, F is the formula you use to find the points on F. So if I wanted to make a picture of F, okay, I'll raise your hand. You know, what's like, if X is 0, where should I be putting a dot? Hands up, come on, all we know. I'll pay everybody. If X is 0, where should I be putting a dot? I'm trying to draw out. If X is equal to 0, where do I put a dot? Everybody who raises their hand is correct. If X is 0, Alec, where do I put a dot? Pebble for a good try, but no. So if X is 0, where do I put a dot? I'm trying to draw out. Tessa? So Tessa notes, if X is 0, that's less than 3. So I'm supposed to use this formula, so I should end up with a dot at 2. So can I just make the scale, I don't know, 1, 2? So I have a dot right there. How many knew that before she said it? Double. If X is 1, where do I put a dot? Come on, hands, everybody. So you're trying to contact yeah, he's not one to hardly ever move. Oh, I see, to track him down. I got you. 1 second.
Mary,
No worries.
I just thought Alexis would have the spelling and I didn't even think.
No worries. Thank you. All right. Hey, hands up, come on. Who knows? Do I have my pen in my pocket? So if you plug in, we're looking at x equals 1. Where's my pen? Rather hate that.
all right.
There we go. Thank you. What's going on? Refocus. Come on, refocus. Like
3.
I mean, you knew it before she said it. Come on. Pebble. Okay, so look, you're just using, come on, you're using this formula to find points on F. Use this formula to find points on F. The F prime formula, let's do that for a second. So here's F prime. I can graph F prime. Hands up. When x is equal to 0, where do I put a point on F prime? Come on, show me. Don't raise your hand, don't take the pros. When x is equal to 0, where do I put a point on f prime? Reagan? 0, 1, because it says right here that if x is less than 3, x is 0, value is 1. How many knew that? One? Couple? When x is 1, where do I put a dot? Bailey?
Just 1 again.
1 again. How many knew that? Couple. So this is how you're drawing the points on f prime, but all of these points represent the slopes up here. So this curve has a slope so this curve has a slope of 1, and then the slope's going to change to 4. That's why there's a corner right there. Down here, we just have values of the slope. So the slope is 1, the slope is, when we get to 3, we cannot plot anything. We have to leave it blank, because we don't know the slope at 3. That's what the graph of f prime would look like. Follow-up question. Please, Mary.
What does double prime look like? Because you get the derivative is 0.
Yeah, so f double prime, the derivative of each of these is 0, which means f double prime would simply be 0 always, other than still undefined at 3. So if I were to make a graph of f double prime, like that.
Can you find that 3 because of the jump on the prime graph?
Right. No, it's right. The corners on f, the corner on f causes a jump on f prime, and that causes a missing point on f double prime. You can't find the slope of the jump either.
I just want to change that.
Oh, thank you. Thank you.
Large lines.
Give them a couple.
Double. Thank you. Everybody up? No, be humble. Don't forget the Tim McGraw song.
I should know that song.
Good choice, right? I got that one loaded too. That's a good one. Anybody else have questions here? Anybody else have a different question about with the McGraw? Oh, please, Chelsea.
29.
29. Okay, look at the board. Hey, raise your hand if you know how to fill in every blank. Come on, gotta have this memorized. And as we do these little things in class, I would make a list of like flashcards I need to build, or just build the flashcard right away, or something like whenever I ask a question asking you to recall a fact, if you can't recall the fact, you've got to do something to get it in your memory. So, who knows what goes in the blank? Laura? You're talking. Very good. No worries. There really isn't a forward and backwards. I tend to say it the other way because I'm thinking, okay, f goes increase to decrease. That means f prime is going positive to negative. But it's not really forward and backwards, so that's well done. Hands up if you would have said that had I called on you. Hello. Okay, question. So using that, next thing to memorize is the following. I've got to figure out where f does this, or where f prime does what we've stated. I don't have a graph available to me, so I've got to remember sign chart. Sign chart is my method when I can't graph. I prefer to graph, it's easier. But if I can't graph, I'm going to use the sign chart. So here's my work. I'll let you stare at that. The steps are numbered. Feel free to ask about any step. Please, Chelsea.
So I got to step 2, and then I didn't know how to factor the 5x minus 5 4x.
Gotcha. Hey, look up, please. Look up. Okay, most teachers call this a difference of squares. All you have to do is notice the pattern. You're used to seeing x squared, x, and a number, but if they square them again, it still works. So x to the 4th, x squared in a number. I simply ask myself, what multiplies to make 5x to the 4th? So this is not really a difference of squares. My bad, it just factors easily. So this is just 5x squared times x squared. You good there? Next thing, I want all eyes here, all eyes. Okay, I keep seeing people make the following error. Please just get this out of your head. Don't look at this next. It makes the problem hard. Ignore that. Go to here. What multiplies to make 1? 1 times 1. If I'm solving this for the first time, what I would be doing is writing over here. Let's see. I've got. Let's do it on another page here. 1 second. So. Okay. So here's the equation we're trying to factor. We've got 5x to the 4th, subtract 4x squared plus 1. Plus 1 minus 1. Minus 1, thank you. So I drop parentheses. I say 5x squared and x squared. Then I put a 1 and a 1. Hey, look, come on. Now I just multiply it out. So these two are going to become 5x to the 4th. These two are 5x squared. These two are x squared. The last two are 1. Now I've just got to make it all work. So let's see. This has to be negative. This has to be positive. This has to be negative. So this is multiplied. This is created by multiplying these two. So to create a negative, I'd have to have a negative here. X squared is created by multiplying these two. Therefore, I need a negative. Is this plus or minus? This is minus. This has to become positive. We've got to put a positive there. And then everything works. That's how I do it. Any questions on factoring? I know there are other methods for factoring. My advice, this method is the one that is stuck in my brain the longest. Far longer than any other technique I've ever learned. So I just use this. I will for Chelsea for asking. Anything else here? Please.
For just the flashcard, can you say the steps for creating a sign?
Oh yeah, sure. And I apologize every time you ask me for the steps, I probably give you different steps. I don't have like a strict thing, you know what I mean?
Yes.
I really think the most important, let me talk for a second, then you can write it down.
Okay.
I really think that the first thing you really should do is be clear on what you're trying to sign chart. Like I've seen people just kind of out of reflex start doing things without really thinking, why am I making a sign chart of whatever? So number one, remember this kind of a thing. It's like really know what you are sign charting. So that'd be the first thing. Yeah, it depends on the problem. And so you never want to just kind of say, oh, I need a sign chart and just go doing things without knowing why. We know we need a sign chart because of this right here. We're trying to see when f prime changes positive to negative. You can only build a sign chart with factors. That's crucial to memorize. So only build a sign chart with factors. So you list the factors. So I guess the steps are, Paris, identify what to sign chart. Factor what you're going to sign chart. And I guess you would draw your number line. Then list the factors. Then you test, like you have to, I don't know how to say this, you have to determine the zeros of each factor. So you have to find the zeros of each factor. Then you test left and right of each zero. Once you've done all that, you basically, the sign chart's done. So. Double for asking. Anybody else on this one? Chelsea, you good? We have a different one they brought with them to class to ask what they did. Which one? Oh.
Yeah.
Okay, 12 is a really good example of you don't. Okay, so eyes up. I gotta see you looking here. Everybody looking here. Okay. I've been helping some people with the last retake, which we'll be done with that tomorrow. Okay, the last retake. Several people have lost points for this mistake. They'll read a little bit. Their memory will say, hey, I've done this kind before. And then instead of continuing to read, they'll do what they remember. And then when they turn in their test, I say, well, you lost 3 points here. And they're like, why? I'm like, because you did what you remembered, but you didn't do what it says. So don't read and remember and do what you're remembering. Read what's on the paper. Do what's on the paper. So I'll model how I solve AP problems. I don't start reading this. A particle moves along the x-axis. Okay, I know I've read that before, but I don't just jump into, oh, I know what they want me to do. They want me to do. I don't do that. Particle moves along the x-axis so that at time greater than 0, its position is given by this period. Okay, develop the habit. Part of your AP success depends on good habits. A really good habit is when you hit a period, stop. And just breathe. Okay, and kind of see what you've got so far. All we really know now is we have a formula for the position. That's it. I don't make any assumptions about what they're going to want me to do. I just read what they want me to do. At what time is the particle at rest? And now I have a flashcard fact. Particle particle is at rest when? Hands up, who knows? How do I know when a particle is at rest? Flashcard facts, it's just immediate recall. How do I know when a particle is at rest? Immediate recall. It's in your deck of flashcards so that you're never forgetting this. How do I know, Rachel? When the velocity is 0, particle is at rest. How many would have said that? Your hand was raised. Couple. Okay, so I need to figure out when the velocity is going to be 0. So I need to find the velocity. So I do. So I'm taking the derivative. Then I've got to figure out where the zeros are. Zeros are easiest to find from factored form. That's why we're always factoring. Once I've got it factored, I can see where the zeros occur. Right there. So you can ask me any follow-ups to this that you like, but that's the big idea. Anyone else bring a question with them in class? Nate, 24. See here for a minute while we're Nate. Okay, let's do a little flashcard fact thing. The 24 is asking you to find the value of an integral. Pay some pebbles for this. So on the AP test, you're going to be expected to be able to compute integrals 4 different ways. You've actually practiced 3 of them already. The 4th one's pretty easy, so we just kind of let you practice that when you start seeing questions on the AP test that require it. What's one way to do it?
Is the first one area?
So I've got to be careful just a little bit. I want to make sure we don't confuse something. There's 4 ways how we compute an integral, and there are multiple reasons why we want to compute an integral, and area is a little bit unique in that it shows up on both lists. Like we often are asked to find the area, and we have to use an integral to do that. We haven't actually practiced the opposite, but it can happen. You can say, hey, if I can compute the area on a graph, then I can find the value of an integral. So you can do it that way. Pebble for Kenneth, please bring it. Riemann sum. And a Riemann sum, don't forget, is an approximation of an integral. Pebble for Brenna. What other ways, Elsa? Easy. Pick up your calculator. Pebble for Brenna. I'm sorry, pebble for Elika. And let's go, Allison. Yeah, fundamental theorem. Fundamental theorem is where we find the antiderivative, and we plug in the limits, find the change in the antiderivative. So those are the 4 ways, pebble for Allison, that you've got to find an integral. You could have a question there. Please. I've never seen a problem where I use Riemann sum if they didn't specify. Yeah. Never seen one where they, now they may, because I've seen some where they never used the word Riemann, they just said, doing a trapezoidal approximation, but there was a word in there that was enough to remind me that, oh, they want a Riemann sum. Anyone else? Awesome. So here they're just asking for an integral, but because I don't have a calculator and it's not Riemann sum, I've got to use the fundamental theorem method, which means I've got to find the antiderivative. Now, when we go to find an antiderivative, you should have three thoughts as well. Your first thought should be, I've got to use a formula, I have to use a rule. And then your other thoughts should be, and sometimes I've got to do a U sub, sometimes algebra, sometimes fold. But that's what I've got to do so that I can use the fundamental theorem. Questions? This idea is very helpful. If you keep straight in your mind, you know, how we do integrals, why we do integrals. Fundamental theorem means I've got to do the antiderivative first. Here's what I've got to be thinking when I do an antiderivative. Any follow-up questions there? Awesome. So back here, I noticed that U substitution looks best. So,
How do you know?
well, I know there's not a rule. It's too complicated. It doesn't fit any of the rules. They're way too simple. They're much simpler. I actually just thought U sub first because I thought, hey, wait a minute. The derivative of this is 2x plus 2. And 2x plus 2 is exactly the same thing as 2 multiplied by x plus 1. So I noticed that the derivative of the bottom is an exact match to the top, except for a difference in multiplying constant. So that's my go-ahead for doing U substitution. We need to talk through that again. Cool. So that's why I did these steps. I'll let you look at the steps. Feel free to raise your hand and ask about any part of it. I'll number what I thought. Here was my thinking. So, thought of two functions being multiplied. Thought of two possible choices for U, here and here. This derivative matched the other multiplying functions, so that was my selection. I take the derivative, I rearrange. Get this. So there's my substitute for the x plus 1 dx. I've got to change my limits, so here I am changing the limits. And I start working on the new integral over here. So that's the original integral. Now I've changed I've changed some of it. And I've changed some more. This is my final version of the U integral. I find the antiderivative. I find how much the antiderivative changes. Writing the wrong number. Please, Mary.
Anytime you do a U substitution, you always substitute limits.
I do. It's safer because it prepares me for some. There have been AP questions where it's a multiple choice question, and they say, which of the following integrals is equivalent to this integral? So they don't ask you to find the value of the integral. They ask you to find an equivalent integral. Well, right here is the equivalent integral. But it's not equivalent unless I change the limits to U. So I just always change the limits if I do a U substitution. Keep going. No, if I don't change the limits, I would take this step, then I'd have an extra step in here where I would take and replace U with x squared plus 2x. And then I would plug in the x limits. But rather than do that, it's safer to just change the limits at the beginning and then just stay with U to the end. So if you make a u substitution, change the limits, don't go back. Please, 2 pebbles for Mary.
I'm just wondering, isn't, number 13 one side is if the spelling of, absolute value of u from 3 to 8 over 2, is that the one side, or?
Either way.
So we could just put that down on the.
Yeah, 1/2 times or 1/2 or divide by 2 is the same thing.
I feel like that would be more simplified than
Well, it's multiple choice, so I had to match what they gave. FRQ, I would have stopped here. 'Cause you don't have to do anything after that. Good for Aaron. Barry, you good? Anybody else? Anyone else bring a question with them to class? Please.
On number 3, I was just confused how to get from step 6 to step 7.
Oh, awesome. Hey. We'll play the pebble game here. So everyone in the room can pick up pebbles. Factoring is essential for the AP test. So right here, I see that f prime of x. I'm thinking, okay, look.
Oh,
Are you done? You got it?
I got
Oh, all right. Game over. Anybody else have a question?
hard. Sorry.
Yeah, I'll do it anyway. Okay. Here we go. Look up. Okay, 2 mathematical words that you need to have memorized because it makes talking about the problem easier are the words term and factor. Okay, when I view f prime as terms, I'm looking at chunk plus chunk plus chunk. They're like stuff plus stuff plus stuff. So please, we'll do this game. You guys know how to play it? So show me on your hands, how many terms of f prime do I see? 1, 2, 3, 4, 5. Show me that line. Right here, line 6, how many terms do I see? Okay, the word term means stuff plus stuff plus stuff plus stuff. That's what a term is, like this stuff plus another term is this stuff plus another term is this stuff. So how many terms do I see here? Show me your hands. 1, 2, 3, 4, 5. How many terms? If you're doing this, give yourself 2 pebbles. Okay, this is 1 term plus the other term. Pretty good? Lots of people have trees. Question? Okay, next thing. This term is comprised of, meaning it's made up of several factors being multiplied. So I can see this term as stuff times stuff times stuff times stuff times stuff. Like a certain number of factors multiplied. Show me in your hands. How many factors do I see multiplied here? Show me. How many factors do I see multiplied here? Show me in your hands. Right here. How many factors? Like stuff times stuff times stuff times stuff times stuff. How many factors do I see being multiplied? Show me. Just this right here. In this term, hey, in this term, how many factors do I see multiplied? In that term alone, how many factors do I see multiplied? Doing this, give yourself 3 more. Pebbles. The factors are 1 minus 2x multiplied by 1 minus 2x multiplied by 1 minus 2x. Any follow-up questions? Please.
Okay, so on step 7, how it gets to 1 minus 8x, I get it, kind of. I don't understand why the negative 6x doesn't multiply into the 1 minus 2.
What you have here, if this had parentheses like this, then the negative 6x would need to multiply in. Because there are no parentheses, it's not multiplication. It's addition or subtraction. So what you really have here is these two parentheses serve no purpose. Because there is no number here other than 1. Nothing here next to the parentheses. No exponents. So the parentheses aren't doing anything. So you just got 3 terms being added. So you can add the like terms.
So if the -6 was in the front,
Then it would need to multiply. That's very good. That's really good observation. So you're looking at the difference between this, parents. If I have 1 minus 2x minus 6x, there's no multiplication at all. These 3 terms just add, and I end up with 1 minus 8x, as you see here. But if it were this situation, now because the -6x is multiplied by what's in the parentheses, I would have to distribute. And I would end up with -6x plus 12x squared. Is that your question?
Yeah.
Couple. Anybody else? Please, David.
Number 4, I got mixed up between step 2 and 3.
Okay, so you're good here, Prentice. Anybody else have a follow-up here? Again, just pay attention how you feel. If you just relax and just say, hey, wait a minute, something's not clicking, and you just talk about it, then it gets better.
So how come like on step 6, where the -6x is in front of that, how come we switched it to step 7? Yeah.
Gotcha. Let me ask you again some questions. Everybody, eyes on the board, everybody, everybody. Okay, right here we identified 2 terms. This term is made up of 3 factors. Show me in your hands, how many factors make up that term? Come on, show me. How many factors are multiplied to create that term? How many factors are being multiplied to create that term? I'm going to give a little hint because I'd like to make sure we all have the same answer. I'm going to treat 6 and x as separate factors. You could think of it as 2 times 3 even if you wanted. But I'm just going to think of it as 6 times x. So there's 2 factors, but in total, how many factors do I see here multiplied? Show me. Or more uniform in our answer. Down 4 pebbles. Okay, look up. Well, I got to empty the jars. All right. Look. Okay, when you factor, you first identify the factors, and then you divide out and multiply back in the common factor. You do that simultaneously. So the common factors are 1 minus 2x squared. There are 2 of those factors in each one. So that's going to come out and be a multiplier. But to get it to be a multiplier, we've got to divide it out. So this divided by this gives me this. Anyone need me to say that again? Wave at me. Then this divided by the common factors results in just -6x. So that's why I didn't ever distribute or anything. I just factored it out. Is that your question? Good. And actually, right here, Emily, I cannot distribute because of the squared anyway. So, 2 pebbles for Emily. Mary, please.
I'm sorry, what?
No.
How do you get 1 minus 8x? I know how you got everything else, but.
Which one?
On line 7. Just the 1 minus 8x.
So right here, okay, you tell me, and if you're wrong, it doesn't matter. Just got to see how you're thinking. Is there anything operating on those parentheses? Operating on means is anything multiplied or divided or an exponent or something? No, there's nothing. There's no number here, here, here. There's nothing. So I don't need those. So all I have here are 3 terms. 1, 2, 3. Okay, I can only combine terms if they're the same type of term. But these 2 are the same type.
Could you not multiply -6x by 1 minus 2x?
Because there's no parenthesis here or here, it's not multiplication. Anybody else? How about for Mary? Somebody had a different question, I forgot what it was.
Number 4.
Hold on a second.
Yeah. What happens with the -1?
What is negative 2 plus 1? What's negative 2 plus 1? Just do the
Okay, so -1.
yeah, so it's right there. Yeah, so what happens when
Okay, so then when did we plug in the 2 and then the 1 on the?
not until here.
Those are the change. Those are the change.
Yeah. So what I did is I said, okay, you good to hear?
Yeah.
And then basically, okay, all eyes on the board. Look, come on, look here, look here, look here. Okay, I'm showing lots of steps. It would be easier for everyone if I could show fewer steps. So if y'all can get comfortable with one idea, we can show fewer steps. Dividing by -1, multiplying by -1, same thing. Not if that feels comfortable. Okay, so right here when it says divide by -1, I just mentally just kind of ignore that for a second. Just leave it on the side. X to the -1 is the same thing as 1 over x. But I gotta remember that I'm still multiplying by a -1. Are you good to hear?
Yeah.
So now I plug it in. So there's the -1 over the 2 minus -1 over 1. I just do the arithmetic.
I guess my question is, how do you know when it's the right time to plug those back in?
All eyes on the board, everybody, come on, look. Okay, this symbol means take whatever this is and find the change from 1 to 2. So I'm just reading the symbols. There's no right time other than I just kind of waited till that was easy to work with. I looked it up one time and could not find any name. There were lots of talk on the internet about, "Ooh, what's the name of this thing?" And people could all describe what it meant and how to use it, but nobody had a name.
Just the bar.
This is just the bar, I don't know. It's finding the change, it really is. Like, you can think of it, you know. You can find the change in this from here to here.
I know you already said this or explained it before, but where does the plus C go when you're using the bar?
It ends up subtracting out to 0 anyway, so no one expects you to write this. Emily?
So on step 3, you have like 1 over -1 and then -1 over 1. Like, I get that it doesn't really change anything, but like, why did you switch those?
Oh, because I was creating solutions that you're going to read on your own, I was trying to not let anybody get lost. And I just thought maybe it's easier to think of it as multiplication versus division. It wouldn't really matter. You
Yeah.
could have written 1 over -1 times x. Please. Okay, 19 is a great example again of do not read, remember, and then do what you're remembering. Read and solve the problem that you are reading. And don't read and remember, read and solve. So here's the way I would do it. And please notice how slowly I read. This is how slow I read when I'm actually solving the problem. Like, I don't read slow for you, I read slow for me. But I still get frustrated when I have people reading so fast, that's why they make mistakes. The radius of a sphere is decreasing at a rate, keyword rate, 2 centimeters per second. So as I read that, I hit a period, so I stopped, kind of thought for a minute, and I wrote down a key fact. That means dr dt is equal to -2. Has to be negative because the radius is getting less. That's how slowly I would have gotten to that point in the problem. Just that slow. Question? Keep reading. At the instant, the word instant reminds me that in related rate problems, they're usually talking about things changing over time, and they're interested in one moment. So I'm kind of thinking related rate now. At the instant when the radius of the sphere is 3, comma, I stop and breathe. Radius is 3. Let's write that down. Radius equals 3. Like, this is literally me thinking through the problem. What is the rate, keyword rate, of change? And they give me the units in square centimeters per second. I kind of just ignore that for a minute. I don't really pay attention to that. What is the rate of change of the surface area of the sphere? So I wrote that down. The SDT's got to equal something. They'd like me to find it. So anyone want me to repeat how I slowly but surely get this stuff written down? Just very carefully. I'm not doing it fast. If you do it fast, you make a mistake. You don't have to work fast on the AP test. The AP test is time, but you don't have to work fast. It's not like the ACT. It's not a race. It's like, do good work, you'll get a good score. So, okay? But that reminded me that they're giving me a rate, they want another rate, so that's a related rate problem. So I wrote down the acronym. I still have a lot of students who call me over for help, and I'll say, do you recognize that it's related rate? They go, yeah. Do you remember the acronym? They go, DREAD. I'm like, well, why didn't you write it down? Like, seriously, they'll say, I'm stuck. I'm like, well, write down the acronym. Like, go through the acronym. D says make a drawing. That was dumb, okay? Not really helpful. Draw Danica's chart. That is helpful. Amount and rate. They mentioned the rate at which the radius changes. They mentioned the rate at which the surface area changes. So I've got the corresponding amounts. R was read and write down all the rates. I've done that. Write an equation that involves the amounts. Well, they gave it to me. D says take the derivative of that equation with respect to time. So from there, I just basically just take the derivative and plug in. There really wasn't a whole lot else to do. So the follow-up questions, I'll remember the steps. Follow-up questions there. Oh, I'm going to pay pebbles today because I don't want to get too far behind. So, we're still going to have the vessel of hope. So,
So if we have like leftover points from last term, do we get a roll of others?
so the leftover points you should have just used up on tickets. So we'll
No,
start.
it didn't equal it.
Oh, that's okay. There's the key there, so that's okay. Heavy backpack's a good thing. It's a sign of honor.
something awkward happens in that pause, it's even more.
But they're not alphabetical.
No touching until the distribution is complete.
Chelsea would wear just a sock, you know. It's all for that sucks at I have lifetime with them. He's a horrible forward.
Don't touch that. That's how I count is by miles. You would know. Swan counting. Swan counting, you can't be moving them around. At least try. Ah, well,
After school, me and Becky also did you like my video? You can take that car. Okay.
I can't see the best thing. Because I might just get more mad.
I won't.
You call me and I'll say,
I'll say, Danny Bay, I need you.
I'll say,
You have to.
no, I don't.
God astronomy. God astronomy. God astronomy. You're never hitching up to my house again. So wait, what class did you have?
You are
I won't go there. So we're going to nationals after second period. Yeah, David's getting his
So on cap lab, you check things.
That's okay.
Why? Just get the 4-day pass.
You're kidding me. That was shots fired.
So are they done now?
Tomorrow
That's what's in my
no, sorry. Thursday.
Last Saturday.
With mango. I'll continue to get for you.
So they're all done?
Yeah.
very first one's not done.
This one's not done yet, but the other.
What was that, sorry?
I don't know. I found the new one, but I still have like one sentence that seems like a course.
I mean, like, today.
Today, working on hair. I don't need to go to Walmart. Just
I do.
Very good.
guys, here's the
Also need a So you have pretty levels there too. No, they're there.
Oh, they are?
So they get credit for they get credit as test points. We're checking. Just ready to show with your throw.
Yeah, it happens a lot, actually.
That's what your mom said.
I have to get my glances out. 2 days and 40 days.
40 tickets, $2. Cool.
And then, can I get a white practice test? Is that what it is?
So the white is, well, I guess they're all practice tests, but the white is the one they want you to do without notes.
Yeah.
It's in the front, so grab the packet for us.
I didn't have all my tickets. My test score because I was absent, so I have 44. My grade is easy.
What's that?
Yeah. It's okay. What?
You got some zeros somewhere.
Yeah, okay. And okay, wait. No, no, those are accurate. Those are accurate.
You get your homework done.
Yeah. Casually. If you get your homework done, yeah. Yes, I know. It's just my life is honestly insanity. Okay, I will have the green one done and the white one.
Okay, just let me know.
Okay.
Okay.
I will get the green ones in and that will help.
Yeah. Very good.
Oh.
Okay.
So, I'm just wondering if I can retake the unit